Fabulous Chemistry Faithful, video number 3. Let's get into what on earth an acid or a base is. So first we have to use the Arrhenius, is how you say his name, theory, and then we have to learn the alternate acid-base theory in this particular lesson. So here we go. What exactly are acids and bases? Well, acids react with water to produce an acidic solution. We just talked about what solutions were all last unit. Bases react with water to produce a basic solution or an alkaline solution. First theory, here we go. So, and they're said like this, so you just got to really kind of memorize this straight up. Acids are compounds that release H plus or H3O plus ions as the only positive ion in solution is the first theory. Okay, so basically acids have H plus. Bases are compounds that release OH minus as the only ion in solution. Here is a picture of H plus going into water and making H3O plus. This is what I can draw for you on the board to prove that if H3O is around, then H plus is around. Okay, and we're going to make one little switch about how we talk about water to help make this happen. Okay, formation of H plus with an Arrhenius acid. So this particular graphic shows you what's going on. I do have a packet here, so let me just double check to make sure if I actually want you to write this down. There are 3 scalar Arrhenius acid. So it looks like you have some room for where it says general rules for acids and bases. So this is the formation of an acid. You see how H3O plus is on the other side when the H comes off of this HCl and goes onto the water. So yes, you do have to write that. Oh, I see there's a whole space. So I see we're not even under general rules. All right, good. So now Arrhenius base. Yes, you have to write this equation. You don't have to write all the words underneath, but yes, the equation, so you can see how the OH is there, and that's just from the dissociation, and water wasn't even in that as a product. All right, general rules for acids and bases. Acids produce H plus, and H is usually the first element in the formula. If you look them up, HCl, H2SO4, right? That's hydrochloric acid and sulfuric acid. Bases produce OH minuses in solution, and OH usually ends the chemical formula. If you look on your periodic table or your reference tables, not the actual periodic table, but there's a reference table of common acids and bases, you'll find there's 4 of them. 3 of them have OH and 1 doesn't, and that is the problem with the Arrhenius theory. There is a base that does not have OH in its formula, so that it can produce OH minus directly, like how we just saw NaOH do it, and literally just dissociate it into Na and OH. Well, NH3 can't do that. Okay, so another theory is needed to modify, right? So this alternate theory was needed to explain the behavior of compounds like NH3 ammonia, because this compound does not have OH in it. So we had to modify the theory. So here comes the modification of the theory, which is also correct. And now you have new words. Here now we talk about donate and accept. Everything's going to be in terms of H plus now because it doesn't have OH. Okay, a Bronsted-Lowry acid is any compound that's able to donate an H plus ion to a water molecule, making it H3O plus. So that definition is fairly similar to the Arrhenius theory, but the base is definitely different. Now we're going to say any compound that is able to accept an H plus ion that has been donated by an acid. Okay? And you'll find that that's why the acids and bases go together. And then here comes the theory of what's going on. So what happens is the NH3 base becomes NH4 plus, which is called the ammonium ion. Okay. When water loses an H, it becomes OH minus. And that's how it's produced, and why NH3 is actually a base, because when you put it in water, all of a sudden there's a whole bunch of OH minuses running around, but NH3 doesn't have that OH to dissociate out of it. So it makes it indirectly by scooping up the H off of the water. Okay. NH3 accepts an H plus ion from the H2O molecule, creating a leftover OH. Therefore, it is created indirectly. So we had to change the theory. So now we call it a hydrogen acceptor, an H plus acceptor. Then identifying ions, or identifying the ions they'll make. Well, we know that an acid is always going to make H plus. So HCl is going to go, plus water is going to go to H plus and Cl minus plus water. That's what it'll turn into. It's going to split apart, H plus Cl minus. It's called dissociate. And let's see if there's another one. H2SO4. It's going to make two H's plus an SO4 in water. So we call that a diprotic. And then the bases, same way, they're going to straight dissociate into NH plus and OH minus. You got to know OH is a polyatomic ion called hydroxide that stays together. And that's it. I mean, you can do the rest of these two. They're all the same. NH3 is a little bit funnier, but we kind of worked it out in that picture so you can see it. So first video is done. First real video of the unit's done. And I didn't tell you the trick that we're going to do, but I'll just start out by telling you we're going to call water, this unit, HOH instead of calling it H2O. We're going to make a little change with how we talk about water. We're going to call it HOH. That way, when I split it into OHs and H's, it's easier to see. And that's going to help us with acids and bases altogether. Done with video 3.